This is Sravanthi, working as Assistant Professor of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss a topic is types of electrodes. So in previous class already we discussed what is electrode, electrode potential and electrochemical series. So today we are going to discuss types of electrodes and what is reference electrode, how to classify reference electrodes, and also we can discuss construction and working function of standard hydrogen electrode and Calomel electrode. So first we discuss what is meaning of electrode. So electrode is a metal or metallic rod which conduct electrons. Electrode is a metal or metallic rod which conduct electrons. Generally in electrochemical cell it consists of two electrodes. One is anode and the other one is cathode. So each electrode along with the electrolyte consists a half cell. For example, here zinc and copper galvanic cell. In this, zinc always acts as anode, copper acts as cathode. So for example, zinc electrode. Zinc is a electrode which conduct electrons. So here zinc acts as anode. So always at anodic area, oxidation reactions takes place. So when the zinc electrode dipped in zinc sulfate solution. So it considered as one half cell. So zinc electrode dipped in zinc sulfate solution, it is one half cell, oxidation half cell. For example, copper electrode dipped in copper sulfate solution. In this case, it acts as reduction half cell. Reduction half cell. So these two half cells is considered as cell, electrochemical cell. So an electrochemical cell, it consists of two electrodes, anode and cathode. Here at anode is the electrode at which oxidation reactions takes place. So already we know that oxidation means loss of electrons. For example, here zinc electrode where it is dipped in zinc sulfate solution. So already we know according to electrochemical series, zinc always acts as anode. Why? Because according to electrochemical series, above the hydrogen scale metals, all those are acts as anode. So in this electrochemical series, zinc present above the hydrogen scale, so that's why it acts as anode. So here zinc is a metal, that means it acts as anode. So at anodic area, oxidation reactions takes place. So zinc undergoes oxidation. So oxidation means loss of electrons. So next coming to the cathode. Cathode is also one of the electrode at which reduction reactions takes place. Reduction means gain of electrons. For example, according to electrochemical series, copper acts as cathode because it is present in electrochemical series below the hydrogen scale. So already we know that below the hydrogen scale metals all are having cathodic nature. So copper acts as cathode. So when we dip this copper electrode in copper sulfate solution, so it acts as cathode. So cathodic area, reduction reactions takes place. So copper gain of 2 electrons then gives copper. So this is 2 electrodes present in this cell. So what is the meaning of electrode? It is a metal or metallic rod which conduct electrons. So there are two types of electrodes, anode and cathode present in electrochemical cell. At anodic area, oxidation reactions takes place. At cathodic area, reduction reactions takes place. This is the basic concept of electrodes. Now we'll discuss types of electrodes. So there are 5 types of electrodes. One is metal ion electrodes, gas ion electrodes, metal insoluble salt anion electrodes, inert oxidation reduction electrodes. It is also called as redox electrodes. It is also called as redox electrodes. And also 5th one is membrane electrodes. This membrane electrode is also called as ion selective electrodes. So there are the 5 types of electrodes. Then these all 5 types of electrodes used as the reference electrodes in different electrochemical cells. So now we'll discuss first one, metal ion electrode. So this is the simplest type of electrode where metal is dipped in a solution of ions. So it is a very simplest type of electrode, metal ion electrode. So just now we discussed already any metal, either zinc, copper, silver, any metal, it is dipped in own salt of ions of the electrolyte solution. It's called metal ion electrode. So for example, just now we discussed already zinc electrode. It is dipped in zinc sulfate solution. The zinc metal, it dipped in same own ions present in that electrolyte solution. So best example of metal ion electrode. And one more example is here given silver rod. The silver rod is dipped in silver nitrate solution. The same metal, it is dipped in same metal ions present in that electrolyte solution. Is called metal ion electrode. Second type is gas electrode. Best example is standard hydrogen electrode, gas electrode. So here in this gas electrode, it consists of platinum, acts as a inert electrode. This gas electrode, it consists of platinum, it acts as a inert electrode, and continuously 1 atmosphere pressure of gas passes through this glass tube in this HCl solution. So this is the construction of gas electrode. So in this gas electrode, hydrogen gas is continuously bubbled through this 1m HCl solution. Here inert metal is platinum is used. Since here this platinum is not attacked by acid, but the inert metal in electrode does not participate in the electrode reaction, but helps in the making electrical contact. So let the gas bubble here X2. Here we pass 1 atmosphere pressure of gas continuously passed through this glass tube into this HCl solution. So here it is considered X2. And then the electrode is denoted as platinum. It acts as a inert electrode, and here hydrogen gas, 1 atmosphere pressure of hydrogen gas passes through this glass tube, and this is the HCl solution. This is a construction of gas electrode. Best example is standard hydrogen electrode. So it is represented as platinum. Already we know that in this gas electrode, it acts as inert electrode, and 1 atmosphere pressure of hydrogen gas continuously bubbled through this glass tube into this HCl solution. And this is H plus ions present in this HCl solution, 1m. 1 molarity of HCl solution taken in this beaker. This is a construction of gas electrode. The third type is metal insoluble salt electrode. Here, this type of electrode, it consists of metal. It is covered by a layer of sparingly soluble salt. For example, here we are taking Calomel electrode. So this Calomel electrode, it consists of solid mercury. So here any metal, for example, in this Calomel electrode, we are taking solid mercury. It is covered by sparingly soluble salt. That means it is covered by mercurous chloride. Here Mx. X means here, M means metal, X means any halide ion present in it. So metal covered, the solid mercury is covered with mercurous chloride paste, and it is dipped in electrolyte solution. The same halide ions present in that electrolyte solution. For example, here we are taking KCl solution. So metal insoluble salt electrode means this type of electrodes consist of metal. It is covered by a layer of sparingly soluble salt. Dipping into a solution containing a common ion. That means same halide ion present in that electrolyte solution. So this electrode is represented as metal. Here metal. For example, in this Calomel electrode we are taking mercury. Metal halides. That metal is covered by sparingly soluble salt. So in this Calomel electrode, the Mx is mercurous chloride. And this 2 lines indicates salt bridge. This 2 parallel line indicates salt bridge. And here X minus, that means same halide ions present in that. That means here in this Calomel electrode, chloride ions, chlorine, bromine, iodine, these are acts as the halides. So in this electrode, we are taking chlorine. And same chloride ions present in this electrolyte solution. So this is a construction of metal insoluble salt electrode. Best example is Calomel electrode. So already we know that it consists of solid mercury. It is covered with mercurous chloride and it is dipped in KCl solution. This is Calomel electrode. One more example also given in this silver chloride electrode. So in this silver wire or silver metal, it is coated with silver chloride. It is coated with silver chloride in KCl solution. This is the best example of metal insoluble salt electrodes. Fourth type of the electrode is oxidation-reduction electrodes. It is also called as redox electrodes. So both reactions takes place in that electrode only, either oxidation or reduction. So that electrodes are called redox electrodes. In this, immersion of an inert metal, generally we are using here platinum. It acts as a inert electrode dipped in a solution which contains two ions or molecules with the same composition but different state of oxidation. That means here, for example, we are taking here platinum electrode, taken as example for this redox electrodes. So here platinum electrode used as a inert electrode. It is dipped in electrolyte solution. This electrolyte solution containing ions or molecules with the same composition but different oxidation. For example, this platinum electrode dipped in this ferrous sulfate solution. So in this solution, it containing same concentration but different oxidation state of ions present in this Fe+2 and Fe+3. Two different concentration of ions present in this electrolyte solution. So this type of electrodes are called redox electrodes. Now coming to the fifth type of electrode, that is ion selective electrode. It is also called as membrane electrode. This electrode is mainly used for determination of specific ions present in electrolyte solution. For example, you are taking HCl solution. When we are using this glass electrode, we can use it for determination of H+ ions present in that HCl solution. It is also used for determination of pH. So best example is glass electrode. Glass electrode is the best example of ion selective electrode. So this type of electrode possesses the ability to respond only to certain specific ions present in that solution. So now let's discuss reference electrode. So all these 5 types of electrodes used as a reference electrode in different electrochemical cells. So what is the meaning of reference electrode? So reference electrode means the electrode of standard potential which we can compare the potential of another electrode is called reference electrode. That means reference electrode means known potential of electrode. Already we know the potential of that electrode. We can use it for determination of another electrode potentials is called reference electrode. So all these 5 types of electrodes used as a reference electrode in different electrochemical cells. So by using this reference electrode, we can determine the electrode potentials of other electrode. So here, these reference electrodes are classified into 2 types. The first one is primary reference electrode and secondary reference electrode. So primary reference electrode, best example is standard hydrogen electrode. So standard hydrogen electrode is the primary reference electrode and its electrode potential is 0 at all temperature. Electrode potential is 0 at all temperature. But its setup is very difficult. So to overcome these difficulties, problems, we are using secondary reference electrode. Best example is Calomel electrode, Pinhydrone electrode, glass electrode. So these are the reference electrodes. So reference electrodes means known potential of electrode which we can use it for determination of electrode potential of other electrodes. It is considered as reference electrodes. So now we'll discuss construction of standard hydrogen electrode. So standard hydrogen electrode, it is the best example of primary reference electrode. Its electrode potential is 0 at all temperature. So how can we construct this standard hydrogen electrode? So it consists of platinum foil. It consists of platinum foil connected to the platinum wire. This is a platinum wire. So the standard hydrogen electrode, it consists of platinum foil. That means it is covered with platinum black, and it is connected to the platinum wire, and it is sealed in a glass tube. This is a glass tube. It is sealed in a glass tube, and this total syrup is dipped in 1 molar HCl solution. 1 molar HCl solution. This is the construction of standard hydrogen electrode. In this, 1 atmosphere pressure of hydrogen gas is continuously bubbled through this glass tube into this HCl solution. So here, the electrode potential of standard hydrogen electrode is 0 at all temperatures. This is the construction of standard hydrogen electrode. So here, this hydrogen electrode, in this we are maintaining standard condition. That means, for example, whatever standard conditions, pressure is 1 atmosphere pressure and temperature is 25 degrees centigrade and concentration is 1 molar. In that we can find out the electrode potential of that electrode, that is value is 0.0 volts. So this is the construction of standard hydrogen electrode. So this standard hydrogen electrode acts as anode and cathode. It depends on nature of half cell. For example, the standard hydrogen electrode acts as anode. So in this case, the standard hydrogen electrode, if in case it acts as anode. So already we know that at anodic area, oxidation reactions takes place. So hydrogen gas, it undergoes oxidation, then gives 2 H plus ions and loss of 2 electrons. Why? Because it is a oxidation reaction takes place at anodic area. If in case it acts as cathode, so cathode means at cathodic area reduction reactions takes place. Reduction means gain of electrons. So at cathodic area, this 2H plus gain of 2 electrons then gives hydrogen gas evolved at cathodic area. So the standard hydrogen electrode acts as anode or cathode, depends on nature of half cell. If in case it acts as anode means it undergoes oxidation, then gives H plus ions and loss of electrons. If in case it acts as cathode, it undergoes reduction reactions, then at cathodic area, this H plus ions, gain of electrons, then evolve H2 gas at cathodic area. So the standard hydrogen electrode represented as H plus aqueous solution, that means HCl solution, and this parallel line indicates electrode and electrolyte solution separated. And this hydrogen gas is continuously passed through the glass tube, side arm of the glass tube, and the pressure is 1 atmosphere pressure. And here platinum electrode acts as the inert electrode dipped in this HCl solution. So this is the working function of standard hydrogen electrode. So now discuss what are the applications of standard hydrogen electrode. So it is mainly used for determination of standard electrode potential of any electrode by using standard hydrogen electrode. This electrode is mainly used for determination of any other electrode potentials by coupling with this SHE, standard hydrogen electrode. For example, here we are taking determination of standard electrode potential of zinc electrode by using SHE. So generally, it is highly impossible to know the absolute value of single electrode potential, because if in case we tried this, in this case that metal if in case undergoes oxidation or reduction, it takes place independently. So hence we find the relative potential by coupling it with a reference electrode. That means standard hydrogen electrode, it acts as a reference electrode. So what purpose we are using this reference electrode? We can determine the electrode potential of unknown potential of electrodes by using or by coupling with this reference electrode. So here standard hydrogen electrode is used for determination of electrode potential of other electrode. So for example, here this determination of standard electrode potential of zinc electrode by coupling with standard hydrogen electrode. So without coupling with standard hydrogen electrode, it is highly impossible to calculate the single electrode potential of that electrode. Why? Because it is undergoes oxidation or reduction. That's why any electrode, which electrode we can determine the electrode potential of that electrode, we can couple with standard hydrogen electrode or any other reference electrode. So in this case only we can calculate the reduction potential of that electrode. So for example, here we can determine the zinc electrode potential. So here zinc electrode, this is a zinc electrode, it is dipped in zinc sulfate solution. It is a oxidation half cell. It is a oxidation half cell. But it is coupled with standard hydrogen electrode. Why? Because we can calculate the zinc electrode oxidation potential. That's why we can coupled with standard hydrogen electrode. We can couple with standard hydrogen electrode. So this cell is represented as here zinc acts as anode and it is dipped in zinc sulfate solution. So electrode and electrolyte solution both are separated by a vertical line. And these two lines indicates salt bridge. Already we discussed previous class in construction of a representation of galvanic cell. So here these two lines indicates salt bridge. And H plus ions, these are present in HCl solution in this standard hydrogen electrode. And hydrogen, 1 atmosphere pressure of hydrogen gas passes through this glass tube. And this platinum electrode acts as a inert electrode in this SHE, standard hydrogen electrode. So this is a representation of this electrochemical cell. So here at anodic area. So here zinc acts as anode. So it undergoes oxidation, then gives zinc metal ions and loss of electrons. Why? Because it is a oxidation reaction. Here at cathodic area, reduction reactions takes place. So H plus coupled with the standard hydrogen electrode. So H plus ions gain of 2 electrons, then gives hydrogen gas evolved. Okay. So here, how can we determine the E cell value of this cell? So E cell equal, what is the formula? Standard electrode potential of cathode minus standard reduction potential of anode. So here, cathode value, already we know that standard hydrogen electrode potential is 0 at all temperature. Here we are used as a reference electrode. So that value is 0 minus electrode potential. Oxidation potential of anode is oxidation potential of anode, it is detected by in this voltmeter when we couple with standard hydrogen electrode. So its value is plus 0.76 volts. So E cell value is minus 0.76 volts. So this is the reduction potential of zinc electrode. Standard reduction potential of zinc electrode value is minus 0.76. So in this way we can calculate the standard reduction potential of unknown electrodes by using reference electrode. Here we are using standard hydrogen electrode. Some basic main application of standard hydrogen electrode. Now let's discuss disadvantages of standard hydrogen electrode. So it is quite difficult to set up a hydrogen electrode. Setup is quite difficult. For example, in this construction purpose, we are using platinum foil. If in case this platinum foil touches the surface of the beaker, in this case it is more poisonous. So it is very careful. So it is quite difficult to set up of a hydrogen electrode. This is the main disadvantage of standard hydrogen electrode. And it cannot be used in solution containing redox systems. In this case also, we cannot use this type of electrode. And one more disadvantage is, it is also affected the compounds of mercury, arsenium, sulfur, and also some of the oxidizing agents like ferrous, manganese oxide, chromic acid, chromate, and such type of oxidizing agents or any this type of compounds present in the solution. If in case we are using standard hydrogen electrode, it is easily affected by that solutions, compounds or oxidizing agents. So in this case also, we cannot use this standard hydrogen electrode. So these are the disadvantages of standard hydrogen electrode. So one is, it is quite difficult to set up a standard hydrogen electrode, and it cannot be used in redox systems, and it cannot be used in the compounds which are containing, that means mercury, arsenium, sulfur, or some of the oxidizing agent like chromate, ferrous, manganese oxide. So in this case also we cannot use the standard hydrogen electrode. Now discuss Calomel electrode. So Calomel electrode is a secondary reference electrode. Calomel electrode is a secondary reference electrode. So here this electrode also mainly used for determination of electrode potential of other electrodes, unknown electrodes. It is mainly used for determination of electrode potentials and also used for determination of pH. In this case we are using this Calomel electrode. So this Calomel electrode, it is commonly used, so just now we discussed, it is used as a secondary reference electrode and it is used for measuring electrode potentials. So the Calomel electrode, it consists of solid mercury. It consists of solid mercury, mercurous chloride and KCl solution. It consists of solid mercury, mercurous chloride and KCl solution. So mercury is placed at bottom of the glass tube. For example, here this is a Calomel electrode. So here in this Calomel electrode, already we discussed just now, it acts as a secondary reference electrode. It is used for determination of electrode potential. So this electrode is consist of solid mercury. It is covered with mercurous chloride. It is the best example of a metal insoluble salt of electrode. It is a type of metal insoluble salt of electrode. So it consists of solid mercury. It is covered with mercurous chloride paste. And KCl solutions placed over this mercurous chloride paste. And platinum wire is dipped in this KCl solution. It acts as a inert electrode. It acts as a inert electrode. And this glass tube is having two side tubes. This left hand side tube is used for, which allows the KCl solution in this glass tube. It allows the KCl solution in this glass tube. And right hand side tube is used for to connect the salt bridge. So what is the use of salt bridge? To making electrical contact. To making electrical contact. So this is the construction of Calomel electrode. So it consists of solid mercury placed at bottom of this glass tube and it is covered with mercurous chloride and KCl solution is placed over this mercurous chloride, and this glass tube is having two side tubes. Left hand side tube is used for which allows the KCl solution in this glass tube. Generally in this glass tube we are using saturated KCl solution. And left hand side tube is used for to making to connecting with salt bridge to making electrical contact. And platinum wire is dipped in this glass tube. So this platinum wire acts as inert electrode. It is also used for to making electrical contact the solution. So this is the construction of Calomel electrode. So main thing is here the potential of Calomel electrode. The potential of Calomel electrode depends on concentration of KCl solution. The electrode potential of Calomel electrode depends on concentration of KCl solution. If in case generally we are taking saturated KCl solution, for example we are taking saturated KCl solution. So in this case what is the electrode potential of that electrode? 0.24 volts. For example, if you are taking 1 normality of KCl solution in this glass tube, so what is the electrode potential of Calomel electrode? 0.28 volts. If you are using 0.1 normality of KCl solution in this glass tube, so in this case electrode potential is 0.33 volts. So what is the main thing here? The electrode potential of Calomel electrode mainly depends on concentration of KCl solution. If in case concentration of KCl solution is changed in this Calomel electrode, electrode potential values also change. So this Calomel electrode is represented as solid mercury, mercurous chloride, and this parallel indicates electrode and electrolyte solution separated. So it is represented on parallel line, and KCl solution used as a electrolyte solution. Generally, we are taking in this calomel electrode saturated KCl solution. So that's why its electrode potential of this calomel electrode is plus 0.24 volts. So this is the construction of calomel electrode. So we'll discuss working function of calomel electrode. So it acts as anode and cathode. It depends on nature of half cell. For example, it acts as anode. So in this case, the electrode reaction represented as, if in case it acts as anode. So at anodic area already we know that oxidation reactions takes place. So mercury, it undergoes oxidation, then gives mercurious ions and loss of 2 electrons. Mercury undergoes oxidation at anodic area, then gives mercurious ions and loss of 2 electrons. So these mercurious ions combine with chloride ions from the KCl solution, then gives it mercurious chloride. So the total overall reaction at anodic area is mercury plus 2Cl minus gives rise mercurious chloride and loss of 2 electrons at anodic area. So at anodic area, generally chloride ion concentration is decreases. At anodic area, chloride ion concentration is decreases. Because you are using chloride, that's why this concentration is decreases. If in case this calomel electrode acts as cathode, so in this case, this mercurious chloride undergoes reduction. At cathodic area already we know that reduction reactions takes place. So mercurious chloride undergoes reduction, then gives mercurious ion. First, this mercurious chloride decomposes into mercurious and chloride ions. So this mercurious ions gain of 2 electrons because it is a reduction reaction. Then gives mercury. So overall reaction at cathodic area is mercurious chloride and gain of electrons, then gives mercury plus chloride ions. Here the concentration of chloride ion is increases. The concentration of chloride ion is increases. So in this way, this calomel electrode also used as a secondary reference electrode, and its electrode potential is generally 0.24 volts when we are taking only saturated KCl solution. If you are taking different concentration of KCl solution, that electrode potential value also change. So it acts as a anode and cathode. It depends on nature of half cell. If in case it acts as an anode, in this case concentration of chloride ion is decreases. If in case it acts as cathode, the concentration of chloride ion is increases. So this electrode also mainly used for determination of electrode potential of other electrodes and also used for determination of pH. So today's class we discuss what are the types of electrodes and what is reference electrode, how can we classify these reference electrodes, and how to construct standard hydrogen electrode and calomel electrode. So, thank you.
Like, share and subscribe. Hit the bell icon for more updates.